So Meta's got this new AI model that might just completely flip the script on how AI understands the world. It's called VL-JEPA, and it's taking a totally different approach. See, instead of building sentences one painful word at a time, it tries to get the entire meaning all at once, which, sounds a lot more like how we do.
I mean, think about it. Almost every AI we interact with, its whole world revolves around one thing: predicting the next word. But is that actually understanding? Is it? That question right there, it gets to the heart of this huge bottleneck in AI, and it's exactly what VL-JEPA is designed to smash through.
Okay, so let's dig into the fundamental problem here. Almost every AI that deals with images and text, vision language models or VLMs, they build their answers step by step. It thinks one piece at a time. The super methodical word-by-word process, that's called autoregressive generation. And it's a mouthful, but it's important.
And this right here, this contrast explains everything. On one side, you've got the typical AI. It's slow, it's carefully modeling every single word, every little bit of style. It's kind of like writing an essay by picking one word, then the next, then the next. Super tedious. But then on the other side, that's us, right? We just get it. We grasp the big picture, the core meaning almost instantly. And that massive difference in speed, that creates a huge latency problem for AI, especially when it needs to work in real time.
And look, this isn't just me talking. The researchers behind VL-JEPA, they spell it out. They say these models are super expensive to train because they're wasting all this energy on tiny surface-level details. This whole process of generating text piece by piece, or token by token as they call it, is just way too slow for anything that needs to react to the world as it's happening.
So what's the alternative then? Well, this is where things get really, really clever. Instead of predicting the next word, VL-JEPA is designed to predict the entire meaning of an answer, all at once, as this kind of abstract numerical thing. And the key to all of this is a concept called an embedding. Now, just think of an embedding as a coordinate on a giant, invisible map of meaning. On this map, ideas that are similar, like, say, the lamp is turned off and the room will go dark, they're plotted right next to each other, even if the sentences themselves don't share a single word. So the AI's job isn't to figure out the words, it's to predict a location on this map. It's predicting a concept.
And honestly, this analogy is perfect. A traditional model, that's like getting turn-by-turn directions. In 200 feet, turn left. Then, in a quarter mile, turn right. It's a long, winding process. But VL-JEPA, it just gives you the final GPS coordinate. Boom, here's the destination. It's a single, compact piece of info that has everything you need to know all wrapped up.
All right, so let's dive in. How does this thing actually work under the hood? We're going to take a quick look at the, wait for it, Joint Embedding Predictive Architecture. JEPA. That's what it stands for. Okay, I know this diagram looks a little intimidating, but let's just focus on the main flow here. You've got your inputs coming in, visuals, the text question, and they get fed into the system. Now here's the crucial part. The model's main job is not to spit out words. Its primary goal is to predict that target embedding, that GPS coordinate of meaning we were just talking about. It's only at the very, very end that a separate, much lighter component translates that meaning into a sentence you or I can read. And it only does that when it absolutely has to. All the heavy lifting is about understanding meaning, not generating words.
So let's break that whole thing down into 4 simple steps. First, something called an encoder looks at the visual world and kind of crunches it down into a compact digital format. Second, a predictor takes that visual data and your question, and then it makes its best guess at the meaning of the answer. It's trying to find that GPS coordinate. Third, and this is for training, another encoder creates the correct coordinate for the right answer. This is how the predictor learns from its mistakes and gets better. And then finally, way at the end, a decoder translates that predicted coordinate into actual text, but again, only when we ask it to. Super efficient.
Okay, so this all sounds great in theory, but does it actually work any better? Well, the researchers put it to the test. They did a really strict controlled experiment pitting VL-JEPA head-to-head against a traditional model. Using the exact same data, the same vision encoder, everything was apples to apples. And the results? Honestly, they're pretty staggering. You can see here the blue line, that's VL-JEPA. It doesn't just learn faster. Look how much sharper that curve is. It reaches a way higher level of accuracy on both video captioning and classification tasks compared to the old-school model in red. And here is the real kicker. It gets this much better performance with half the number of trainable parameters. And if you think of parameters as like the knobs and dials the AI can tune to learn, having half as many means it's not just better, it's dramatically more efficient. it's cheaper to train. That's a huge deal. This whole architecture also unlocks this really cool new feature they call selective decoding. See, because the model is always tracking the meaning of what it's seeing, like a continuous stream of those GPS coordinates, it doesn't have to constantly be spitting out text. It can just wait. It waits until the meaning actually changes in a meaningful way, like when something new happens in a video. And then it bothers to translate that new meaning into words. So smart.
And the benefit here is just massive. This selective approach reduces the number of those really expensive text decoding steps by almost 3 times. We're talking a 2.85x improvement, all while keeping the exact same level of performance. For anything like live video analysis, that's a total game changer.
And the wins just keep on coming across other benchmarks. So on zero-shot video tasks, and that just means tasks it was never specifically trained for, it actually outperforms the previous best models out there. It sets a brand new state-of-the-art in predicting what's going to happen next in a scene, and get this, it even beats massive models like GPT-4o at this. And for just standard visual Q&A, it's right there on par with much bigger, more established AIs. Okay, so let's bring this back down to earth. What does all this actually mean for us, in the real world? Why should you care that an AI is more efficient and focused on meaning?
Well, it matters a ton for any application that needs to understand and act in the physical world, in real time. I mean, think about smart glasses that could actually give you help without that annoying lag, or robots that can instantly understand what's around them to navigate and figure out what to do next. This is all about getting AI out of the chat box and into the world with us.
So when you boil it all down, this big shift from predicting tokens to predicting meaning, that's what's going to allow AI to become truly embodied. It's about creating systems that don't just talk about the world, but can actually see it, understand it, and interact with it smoothly and efficiently.
And that really leaves us with one last big question to chew on. For so long, we've basically measured AI progress by how good it is at language. But what if the real path forward, the path to something like AGI, isn't about getting better at predicting the next word, but about getting better at predicting the world itself?